Hello, we are team number 5 of Petronas Twin Towers. Last week, we talked about safety and elevator plan of the building. Today, we are going to look after verticality control of Petronas Twin Towers. Then, let's get to know what is flow-by-flow method. There are many kinds of construction method used in Petronas Tower, but today, we are going to look into flow-by-flow method related to the verticality of the building. Flow-by-flow method is construction method that assemble prefabricated materials like column, slab, exterior and interior walls by piling up. Flow-by-flow method have advantages from typical construction method, such as faster construction period and lower construction cost. In case of typical construction method, rebar placement and concrete pouring is proceed in construction site. So, the average construction period of one floor is 11 days. However, in case of flow-by-flow method, materials are prefabricated in factory and then assembled in construction site. So, assembling the upper part materials with finishing work of lower part is possible at the same time. It saves about a third of typical construction method. It can be well explained by watching construction process of flow-by-flow method. As you can see, construction can be simultaneously proceed in both lower and upper floor. Concrete have characteristic of hardening by time and water evaporation. Steel have characteristic of shrinkage and expansion by changing of temperature. This kind of deformation of members lead to the error of verticality. The structural designer of Petronas Tower, Thornton Tomasetti, suggested the compensation for error to maintain horizontally over 20 years. They suggested 6 to 7.5 mm compensation to design core wall height, which is first placed in construction process. Next, let's look at curtain wall used in Petronas Tower. Curtain wall is often used in skyscraper. As you can see, it is mainly used as exterior wall of the building. There are several reasons for using curtain wall in skyscrapers. Metal curtain wall have strength in lightness and deflection by external force. These days, the usage of PC curtain wall is increasing due to its strength in fireproofing protection. Regardless of all the strengths of curtain wall, if the building has problem in verticality, curtain wall cannot be constructed in place. Curtain wall can be divided into 4 types by structural type, which is mullion type, interlayer panel type, column panel type, and lateral wall panel type. And each curtain wall type is seen as pictured below. Interlayer panel type was used in Petronas Tower. Now, we'll briefly look into lifting and installation of curtain wall. First, we prepare for installation of equipment on lower and upper slab. Then, we install equipment in regular interval and prepare for lifting of curtain wall. Finally, we fabricate lifted curtain wall to equipment by fastener and repeat. All this construction process have required condition of vertically controlled. Next, we'll look into measurement of the building. There is a square structure. If we apply pressure above the structure, it is naturally compressed. In case of constructing with incorrect measurement, there will be serious problem in building stability. Especially in a high-rise building, even 1 millimeter error can lead to 10 centimeter error in 100th floor. It causes serious damage in constructing curtain wall and elevator. In August 1995, during 69th floor core wall construction, there were only 25 millimeter error in Tower 2 built by Korea, while Tower 1 had 40 millimeter more error built by Japan. Considering the construction error, Tower 1 had risk in running elevator system, so they had to stop construction for 2 weeks. So, measurement and compensation in high-rise building is important. Now, let's look into concrete shortening. Generally, there are 3 types of concrete shortening. First type is elastic shortening. Elastic shortening is caused by applied load of building. It is usually caused by increasing dead load as building goes up. The deflection after the placing slab causes stress by giving a slab slope in original position. And we also have time-dependent shortening. Second type is drying shrinkage. It is mainly caused by the water evaporation of concrete member itself. Drying shrinkage consistently happen, but this can be dealt by designing standard test piece using volume, surface ratio, and humidity. Last type is creep, which happens when member is under load. It is proportional to stress and normally happens a lot under early construction load. In conclusion, concrete shortening is caused by elastic shortening and time-dependent shortening, which are drying shrinkage and creep. Concrete shortening of column can cause problems in building verticality. Next, we'll look into construction method and measurement used in Petronas Tower. In constructing process of Petronas Tower, they use strain gauge to measure the concrete shortening. They used each 6-4 core wall, 3-4 main tower column, and 2-4 basalt tower, total of 119 strain gauges. These strain gauges are located in 6 respective floors, and for main tower column, they were located in triangular shape. To measure the concrete shortening in case of main tower, they measure core and shear wall and the external circular column. And for floor materials, they measure steel frame beam and deck plate. In case of basalt tower, they mainly measure external column, which is vertical material. Measurement period is 12 hours after concrete placing till 1 week, 24 hours till 4th week, 5 days till 6 months, 1 month till 1 year, and 3 months till 3 years. Finally, they analyze and compare the data of 3-year measurement and that of designed value. This is the design value and measurement value of concrete shortening in Petronas Tower. Thornton and Tomasetti, who are structural designer of Petronas Tower, suggested correction value for main tower column, basalt tower column, and the core wall. If you look in the charts, you can find out that suggested correction value is bigger than measured or predicted value. This means that TNT maximized the safety and usability of building using higher design value to maintain horizontality of floor material even after 20 years. Through these measurements, the main tower column had maximum of 35 mm camber from core level, and the basal tower column had maximum of 10 mm camber from the main tower column. For total correction value, core wall and main tower column had about 600 mm, and basal tower had about 300 mm of camber. Finally, we'll look into the lifting system. Lifting is a construction process that deals with optimum vertical material transportation using tower crane, hoist, loading deck, and mobile crane to lift up simultaneous multiple construction material and workers. Due to construction period and cost, lifting system is an important issue in case of constructing high-rise building. Petronas Tower is high-rise building and have tapering structure with setbacks. So, to reach above 300 meters high, 4 times of elevator transferring was needed. Due to this condition, in the peak time, it took over 40 minutes to reach high workplace. To solve this kind of problem, they made hoist joining plan to separate low, middle, and high part to effectively put 3,000 workers into work. Petronas Tower have lifting system of 2 luffing tower crane of 32-ton capacity and 4 other lifting cranes. As you can see, luffing tower crane is movable in horizontal and vertical way, and T-tower crane is movable only in horizontal way. Due to narrow workspace in downtown, luffing tower crane was adopted. This luffing tower crane is placed in each tower's lift core. Crane itself also climbs as by building goes up. Petronas Tower have 4 passenger hoists with 3.2 tons of capacity and 90 meter per sec speed, and 1 material hoist with 3.6 tons of capacity and 152 meter per sec speed. 2 passenger hoists are located in ground level, and other 2 hoists are in 300 meter height, where the building is set back. Today, we have looked into verticality of the building. These are our references. Thank you for listening.